one, we will continue to the last chapter, chapter 8, the evaluation of portfolio performance. In the previous lecture, we introduced different measures of the portfolio performance. But now there is some problem, and one is based on different measure. The problem is you only consider all the risk, total risk or the systematic risk. But sometimes we need to consider the downside risk, especially for the stock's price, they goes down sharply, not to goes up sharply. And so in this case, if we consider the downside risk, we need to introduce the Centino ratio. And the next problem is in the previous measures, we don't know the return is from where. So now we need to introduce the performance attribution analysis, especially the return attribution. We want to know whether this return is from the manager's market timing skills or from the manager's stock selection skills. So there are two skills from the manager could help the investor to earn a higher return. One is for market timing, the other is stock selection. So in this part, we will introduce these two attribution analysis. Okay, let's have a look. The first one, Centino ratio. The Centino ratio is the performance measurement with downside risk. So this is very important. It considered the downside risk and measure the portfolio average return in excess of the user selected minimum acceptable return threshold. So definitely from our investor, we will set up a threshold, and if the return is above this threshold, this portfolio investment is better. So that's the threshold downside risk. If our return is below our threshold, which is here, this part, definitely the risk is much higher. And the Centeno ratio, it capture the downside risk. We can use DR to denote the downside risk in the portfolio rather than the total risk as in the Sharpe ratio measure. And also the conclusion is the higher the Centeno ratio indicates a superior level of portfolio management. And the Centeno ratio, the equation is RP minus tau over DRP. So here is the tau, that's the threshold, or in other words, it is the minimum acceptable return threshold. And that's the difference between Centeno ratio compared with the Sharpe ratio. Sharpe ratio, we use the RF. And the next one, the DRP, which is the downside coefficient for the portfolio P. And I will show you later how can we calculate the DR. And the DR has lots of measure for downside risk. One of the most popular measure of downside risk, we call it the semi-deviation. And the equation for this downside risk is based on 1 over n and RIT minus RI bar and square, sum of them together. But now we have a criteria, which is our return should lower than the R bar. So this R bar is the average expected return. So let's have a look. The N here is the number of portfolio return falling below the expected return. So now you need to know what's the average expected return, and you need to count how many individual stock return is lower than our average expected return, and that's the number for this N, and then you can calculate our downside risk. This is the semi-deviation of downside risk. Now I will show you an Excel example to calculate the Sharpe ratio and Centino ratio. Let's have a look. if you are interested about the example, you want to know the detail about that, or you want to ask me about the Excel spreadsheet, you can contact with me. And let's have a look. I gave you two portfolio A and portfolio B, which is from year 1 to year 10 years result. And we find the portfolio A's return for this 10 years is here, and portfolio B's return is here. And also I give you the risk-free rate is, the average risk-free rate is 2%. And now let's have a look. What's the average return for this 10 years for portfolio A and portfolio B? For portfolio A, average return, you can calculate based on Excel equal to average. Use average function to calculate this is 4%. And for the portfolio B, return is 4%. So both of these two portfolios, they have the same average return. Remember what's the Sharpe ratio equation? It should be RP minus RF over sigma P. So if we use the Sharpe ratio, we need to calculate this sigma P. So the next row, I calculate the standard deviation for each these two portfolio. Let's have a look at this standard deviation. In Excel, you can directly use the standard deviation function to calculate that. So you type STDEV and then select all the data here. You can get the result for the standard deviation. It's 5.6% for portfolio A and 5.92 for portfolio B. So these two portfolio, definitely from the result, we know portfolio B, the total risk is higher than portfolio A. So if we calculate the Sharpe ratio, they have the same average expected return and the same risk-free rate. A has lower standard deviation, definitely portfolio A has a higher Sharpe ratio. And based on Sharpe ratio, you will choose portfolio A. So let's have a look. The Sharpe ratio here is equal to the average returns, which is 4% minus this 2% divided by this 5.6%. So we get the result is 0.3569. And same for portfolio B, 0.3381. So definitely based on Sharpe ratio, we will choose portfolio A. But the problem is we go back to our original data. Let's have a look. Portfolio A, the return for this 10 years, you can have a look. We have some big decrease. And for portfolio B, we have some higher increase. So this last two higher increase for portfolio B caused the standard deviation of portfolio B is higher than portfolio A. But for all the investors, this higher higher return is not bad for all the investors. So definitely from the view of the investor, portfolio B is much better than portfolio A, and from the downside here, we not experience that sharp decrease for the stock return. And so in this case, if you consider the Sharpe ratio as the measure of the portfolio performance, it is not better. So we consider the Centino ratio. Now let's have a look. The Centeno ratio, we first need to calculate DR, which is the downside risk. So for the downside risk should equal to 1 over n. And then you use RIT minus R bar square and sum them together and then have a square root here. So let's calculate based on our data, how can we calculate the downside risk for portfolio A? We know it should have, the first one is minus 5%. This is RI minus the average remember, the average return is 4%. So you use minus 5% minus 4% square plus the next one minus 3% minus 4% square, and then you plus minus 2% and minus 4% square, and then you have another 2 is below 4%, so we have 3% minus 4% square, and then the last one is also 3% minus 4% square. So that's all the return is below our expected average return. And then you sum them together and multiply 1 over n. So we have 1, 2, 3, 4, 5. So total 5 return is below your average. So it is 105. And then if you calculate all of this, don't forget you have a square root. So get a square root. Finally, you will get the result for downside risk is 5.8. The same way you can calculate the downside risk for portfolio B, which is minus 1% minus 4% square, and the same until 0% minus 4% square, and the total multiply 1 over 5 and square root. So you get the downside risk is 4.82. So compare with the downside risk, definitely the portfolio B is less downside risk compared with the portfolio A. So based on Centino ratio, we know that it should equal to RP minus tau and over downside risk. So this tau, what's the tau? In this case, we give you this tau, this threshold is 2%. So you can give this threshold minimum level by yourself as an investor. So how can we calculate Centino ratio? This should equal to 4% minus 2% and over 5.8% to calculate the Centino ratio for portfolio A. So based on Centino ratio, we have the portfolio B is much better than portfolio A. So this is the case to show you why we want to consider the downside risk, why the Centino ratio is useful than the Sharpe ratio if we have lots of large volatility, large return. So this large return is not bad for the investor.